Good afternoon, everyone. I'm Sharon Dooley. I'm the moderator for this session. We have a very useful topic today. It's about parameter sniffing, and our speaker is Dejan Savovic from the beautiful country of Croatia. We'd like to thank our sponsor, Quest. Their sponsorship is what makes it possible for us to raffle off gift cards to the attendees, and we are grateful for their support. The summit is rapidly approaching. It's the premier SQL Server event of the year. It's November 6th through 9th in Seattle. Excuse me, I always get a frog in my throat when I have to do this. There are two different discounts. The first discount code gives you streaming access to all past Summit 2017 content, and you can look at all of the presentations that you missed last year when you register to attend this year. The second code gives you $150 US discount, and if you use this code, you'll get a discount off the registration price. For everybody who registers for this summit for the first time with either of our codes, we'll get a Visa gift card valued at $25, which we will offer to our attendees. And for every 20 uses of either of our codes, we will receive one complimentary registration to the summit that we will also raffle off. PASS is always looking for new sponsors, just as Quest is sponsoring us. If you have a company with great content who would be perfect for our community, please use the information on this form and contact Catherine Allen. The next Facebook Live Expert Summit series is going to come on April 24th with Paul Turley, and he will answer your questions. Like and follow our Facebook page for updates on this event. We are one of many virtual groups. You can see a list of them here. If you want to get information from other groups than this one, just go to your PASS profile and check off the groups that you would like to hear from. If you've never been to a SQL Saturday, try to find one. They're all over the place. As you can see from the list on it, it's a one-day free seminar. Usually has multiple tracks with multiple speakers. You can look at SQLSaturday.com to register for an event that's near you. I highly recommend it. It's a very useful event. And join your local chapter. This gives you an opportunity for face-to-face networking, which you don't get from a virtual group. And if there's no group in your area, you can start one. PASS will help you. PASS is an all-volunteer organization. Yes, there are paid staff in the headquarters and all of that, but everything that's done by people, done within PASS, is managed by volunteers. And you can update your volunteering section of your PASS profile. And now I'm going to turn the meeting over to Dan. Dan's been practicing with SQL Server since version 7. which makes him a lot younger than me, but that's okay. His main areas of interest are performance tuning and troubleshooting. And he's an experienced speaker and has given sessions in many different locations, many different occasions, and on SQL Saturday events. He focuses on OLTP databases and occasionally adventures into the business intelligence. He finished an electrical engineering and computing MBA on the Faculty of Economics in Zagreb. His premise was that it is very useful to combine technical knowledge with management process knowledge. He works in Commonus, which specializes in data management field on Microsoft SQL Server. And when he is free, he reads and thinks about SQL Server. It sounds like a terribly boring existence, but it's one that I totally sympathize with, because sometimes I think all I'm ever doing is thinking about and reading about SQL Server. And now I'm going to make Dan the presenter and unmute him so that he can speak. Go ahead, Dan.
Hi to all. Thank you, Sharon, for this beautiful introduction. And welcome all to parameter sniffing on SQL Server session. Sorry about this. Who am I? As Sharon said, I work at Commonus. I live in Zagreb, Croatia. I'm head of data management department at Commonus. I'm a SQL Server MCSE. Have 18 years of experience, and I'm an occasional conference speaker. Agenda for today is we will talk about, obviously, parameter sniffing. We will say a few words when the parameter sniffing is good and when the parameter sniffing is bad. And the most of the presentation will be how to deal with parameter sniffing when it goes bad. We will do this in a long demo, which I hope you will find interesting. And at the end, we will have a conclusion. So let's start. Parameter sniffing. What is parameter sniffing? This is for sure ability of SQL Server. It is an ability that provides SQL Server an option to sniff the parameters when writing plan to the cache. And this gives the SQL Server the ability to reuse the execution plan from cache, meaning that SQL Server doesn't have to recompile or compile the execution plan every time someone executes a query or a store procedure. So parameter sniffing is, I didn't say this, and this is very important. It doesn't only apply to store procedures, it applies to ad hoc queries also. Why SQL Server does that? Why it stores plans to cache and reuses it? Because this way a SQL Server uses less CPU and less memory usage. And this is very important on high-load systems, where you have a lot of queries going on in a second or a microsecond. When is parameter sniffing good? I would say almost always. It will be good when data distribution of your data in the tables are even, and when cardinalities of sets of data execution plan deals with are similar. Quite the opposite of this is when parameter sniffing goes bad. It is when data distribution is not even, cardinalities are not similar, and how do you detect one of the ways? How do you detect the parameter sniffing has gone bad? is that you have queries, the same queries that have duration or reads variation. So you have one execution of the stored procedure or ad hoc query that reads very small amount of pages, and another one when it reads very large amount of pages. Can we deal with bad parameter sniffing? Yes, we can, and there are lots of options to do that. First of them that I would like to mention is optimize for unknown. This is a feature of SQL Server that provides us a way to say the SQL Server optimizer to optimize the passed-in parameters into stored procedure or ad hoc query as unknown values. Then we can use trace flag 4136. This will disable parameter sniffing on the query level, session level, or server level, depending on how we started this trace flag. And this trace flag disables the parameter sniffing at all. Another way to disable parameter sniffing on database level is with alter database scope configuration set parameter sniffing to off statement. This way we can have one database on the SQL Server that has parameter sniffing set to on and another one on the same SQL Server instance with parameter sniffing set to off. Then we can optimize for value. We can say to SQL Server not to optimize on the first creation of the execution plan for the value that was passed in that execution, but to optimize for a value that we specify. For example, we know that some value is predominant in the executions of the queries, and we want to SQL Server to optimize exactly for that value. Then there is an option, recompile option. We can use it on the stored procedure level or on the query level inside of the stored procedure. This means that SQL Server will not store the execution plan in cache. It will recompile or compile the query and make the execution plan on every execution of the query. Then we can use dynamic SQL. This is a way to make SQL Server bring up a different execution plan for different input parameters. We will see this in the demo and it will be more clear when I show it in the demo. Then we can use dynamic SQL with parameters. Also in the demo I will show this. And what does this mean? It means that you are using execute SQL with parameters and specifying them in the params section, in the params input variable of the execute SQL stored procedure. Then you can combine dynamic SQL with option recompile. What does this mean? Well, depending on the input parameters in the stored procedure, you can decide whether you want or don't want to option recompile, and depending on the values of the input parameters, if they are not null, you can include the parameter in the where clause or disclude it if it is null and you don't want to use it. And we came to the demo. The demo will be on the SQL Server 2017. The database I have on this SQL Server instance has only one table. The table is called T questionnaire. It is about questionnaires. It has 3 million rows, and here is the definition of the table. It has an identity primary key, It has client ID, which is not important to us. It's questionnaires that are created for different clients. So this is the purpose of this field. Then we have name, version, date issued, and note that is primarily used just to fill up the pages of the table. Name and date issued are important fields to us because we will do filtering on these two columns. So remember, name and date issued are important columns to us. On both of those columns, we have a single non-clustered index. So we have a non-clustered index on name column, and we have a non-clustered index on date issued column. This is also very important to remember. And the initial store procedure that we wrote looks like this. It has two parameters, name and date issued. And the business requirement is that when the value in these parameters are null, then the store procedure should return all rows regarding that parameter. Very simple. So I have a select statement below, which selects top 10 questionnaires based on name and date issued fields, and I'm saying or name is null or date issued is null to return all rows regarding that column if the corresponding parameter is null. There is nothing wrong about this store procedure. It will do the job. It will do exactly what the business owner told us to do. So it will satisfy the business purpose of this of this business process. But this store procedure, as we will see in the demo, causes the bad parameter sniffing problem. And we will see in the demo how to resolve that problem. In my company, we have developed a web application of which you see two screenshots in this slide. On the top screenshot, you see that I passed in a parameter value Brighton to the name column, and I'm filtering the questionnaires, and I only want to see questionnaires that are named Brighton. And in the result set, you see that I get Brighton, Brighton, Brighton as in the name column. So I passed in the date issued as null, and what happened is that SQL Server compiled this store procedure, sniffed the parameters. The parameter for variable name is Brighton, for variable date issued is null, and for these parameter values, SQL Server compiled and stored the execution plan. Now the second user comes in, and we are looking now at the bottom screenshot, and says, okay, I don't want to filter by name, I want to filter by date issued, and enters February 11th, 2018. And on the left side, you can see that response time of the web application and the database is now 6 seconds. It was previously 385 milliseconds. So something is wrong with this query, with this store procedure, and we have to investigate and see how to resolve this. Let's go to Management Studio now. Okay, here I have my SQL Server 2017 and database parameter sniffing, and the original store procedure PROC3 questionnaire select, which I will alter a few times to show you different options to resolve bad parameter sniffing problem. So I have two parameters, name and date issued, and they are used here as I showed you on the slides, with filtering on name and date issued column and ORing the variable if it is null. Let's go to the web application. I already have inputted the Brighton in the name column. Clicked on start. And right about now, well, it took a lot longer than this that it says. Let's start it again. Okay, 1.5 seconds. Now the second user comes in and says, no, I don't want Brighton, I want February, sorry about this, February, oops, 11. And the response time of the application and the store procedure will be a lot higher, as we saw on the slides. And you are seeing it now. Okay, just about now. This is taking a bit longer than I expected. Just a moment. Let me try again. Let me close the application and start it again. There is always something going bad with the demos when I present them. February 11th, start. Okay. We are executing. Okay, 19 seconds. So this user is angry and he calls you and says something is wrong with the application. The application is taking too long to respond. And what I would do is open up SQL Server Profiler or extended events and start the profiler on the database I want to monitor, and say the user, okay, click again. So the user clicks again, and again the application is not very responsive. Okay, now it took 17 seconds, and in the profiler I get the execution of the application request. I see that the duration is 17 seconds and 152 milliseconds. I will copy and paste this into SQL Server Management Studio. Okay. And here you can see which stop procedure was called. For the name, it was a default value. Default value is null. And date issued is February 11th, 2018. Now, if I execute this sort procedure, I will get the exact same result as from the application. But for the purpose of the demo and educational purposes, I will do something. I will change the session settings for my stock procedure. I will click on set editor board and set it to true. And now, when I execute the stored procedure, I get a quick response. I'm not waiting 17 seconds. I got a quick response. Let me include actual execution plan and set statistics time on and set statistics EO on. Execute it again. Sorry, I executed it without parameters. Sorry, once more. Okay, let's look at the execution plan. Execution plan is like the following. Let me zoom in so you can see on which object the SQL server did a index scan. It was ext questionnaire date issued. So it was the non-clustered index on the date issued column. The first execution, when I started the application, I inputted Brighton for the name column, and then the SQL server generated a plan that you will have to trust me on this, that did the index scan on the index on the name column. So basically, by changing the context settings, the session settings of the query in the SQL Server Management Studio, I actually got another execution plan. I didn't take the execution plan from the cache that SQL Server stored previously, but the SQL Server generated a new plan. Now let's put the set arita board to false. Now I have the same connection settings as the application has. Let me execute this, and now I will get the execution plan that SQL Server stored on the first execution of the application request. And now you can see that it's taking longer. It took 16 seconds. See here, 16 seconds. And execution plan, index scan is on ixt questionnaire name index, which is on name column, non-clustered index. As you can remember, we have two non-clustered indexes, one on name column and one on date issued column. And the problem here is that estimated number of rows, you can see this here, is 52,129, and actual number of rows is 3 million. So SQL Server had to scan the whole table to return 10 rows. Now let's see how can we deal with this bad parameter sniffing problem. Let me just show you something else also. Sorry. Wrong management studio. Just a moment, please. I'm having problems with my mouse. I cannot get to the properties window. View, other windows, no, properties window. Okay. I wanted to show you this parameter list of the execution plan. Let me zoom in. So, date issued has a parameter compiled value of null and parameter runtime value of 11th February 2018. This here you can see if the plan was retrieved from cache. It was, of course, and by difference in these two values, you can tell that your plan was compiled for null and executed for this other value. So this is also an indication that you have a bad parameter sniffing problem. Okay. Let me just copy this stored procedure and prepare it for execution of against name column with value Brighton. And now let's go to the first example of how to resolve bad parameter sniffing with optimized for unknown. So we here have the same two parameters in the stored procedure. The query is exactly the same in the matter of fact, and at the end of the query you have option optimize for unknown. This tells the SQL server to disregard the values of name and date issued that are passed into the stored procedure and basically use an unknown value to optimize it. Use the heuristics of the engine to optimize this query. Let me exit this alter. This alter evicted the stored procedure from cache, so I don't have to execute the dbcc free proc cache to free the cache. Let's go to the application, enter Brighton, clear this one, and start. Now we have 3 seconds for Brighton, and for February 11th, we will get 2.3 seconds. So it's not great. It could be faster, obviously, but it is stable. We have stabilized the query. It gives the consistent response results to the user. Let's see the execution plan of these two calls. I will just execute both of the stored procedure calls, both with name Brighton and both with February 11th, 2018. Okay. I got both responses, and execution plan is obviously the same for the both of the procedure calls because it's cached, and we have a clustered index scan as a method to obtain data from the table. Let's go to next method of resolving problems with bad parameter sniffing. This one is optimized for a value. So we have exactly the same query as before, and we have optimized for hint, and we are telling the SQL server to optimize for name Brighton and date issued 11th of February 2018. Exactly the same values that we are using to query the data on this database. Let me alter the stored procedure, and if I go to the web application and filter for Brighton, Now we get a bit longer response. I will tell you why in a second. I will show you why in a second. Anytime now. Let me do it again. This is not representable. It's not true. Just a second. It says 2.3 again. Okay, let's try with the date issued. So February 11th, 2018. And we get 1.3 milliseconds, seconds. Let's go to Management Studio and execute these two procedure calls one after another to see the execution plans. It's taking a bit longer. This call is taking a bit longer. This one should be faster. Okay, okay. Now we will see the cause of this delay for the first execution. As you can see in the execution plan, the object, the object that was used to scan the table was ext questionnaire date issued. So the non-clustered index on the date issued column. And estimated number of rows was 9. Estimated number of rows was 900. And the actual number of rows is 3 million. So this is why this query for this execution, when we pass in Brighton for name, is slow. The second call has the same execution plan, obviously, and it is using again index on date issued column. Estimated number of rows is 900, and the actual number of rows is 933. So it got it almost correct with the estimations, which are most important for the building the execution plan. Okay, let's go to the next solution. If statements. So if you have a relatively small number of input parameters, you can use if statements to choose a different SQL statement for when the sum condition is met. In this case, I'm looking if name is not null, I'm filtering by name. And if date issued is not null, I'm filtering by date issued. Very, very, very simple. The rest of the query is exactly the same as it was in the previous examples. So, what is the problem with this approach? Well, obviously, when you have a large number of input parameters, this could lead to many possibilities, and you would have to combine them, and the code is ugly, it's hard to maintain, and so on. The other not so intuitive or not so seen on the first time issue is that these select statements are compiled on the first run of the stored procedure, even if the if condition is not satisfied. So when I run the procedure with name equals Brighton and date issued equals null, I will compile this statement also, even though it didn't execute. We can overcome this problem with nested stored procedures, but this is not something that I wanted to talk about. Sorry about this. So nested stored procedures, let me just go briefly through that. You can use a stored procedure here that has only one parameter, date issued, and in that stored procedure execute this code. That would make the SQL server generate the execution plan for that nested stored procedure, and you would overcome the problem of compiling not satisfied if statements, which I just mentioned. So let's alter this stored procedure. Let's go to the application and enter Brighton. Wow, we got 500 milliseconds. And for February 11th, we got even less, 144 milliseconds. I would say, got lucky because the first execution of stored procedure passed in the value null into date issued, which is enough selective to generate a good execution plan for this query. Let's take a look at the execution plans. Let me just, okay. So execution plans are index seek for the first query on the non-clustered index on name column, and for the second one, index seek also on the date issued column, on the index on the date issued column. So this is fine, but it is, as I said, hard to maintain, and you have a lot of duplicate code and so on. Let's go to the next solution. Next solution is option recompile. So we have exactly the same query as we have in the first stored procedure, and at the end we say option recompile. This tells SQL Server not to store the execution plan in plan cache, but to compile it on every run of the stored procedure. Let's see how this behaves. For 400 milliseconds, and for date, we get 37 milliseconds. But as in the previous example, we get two different execution plans at the cost of CPU and memory usage for generating the execution plan by SQL Server. So if I execute this, I will get index seek on name column here. Okay, ext questionnaire name here. And for the second call of the store procedure, as in previous example, I get index seek on date issued non-clustered index. Okay, the next solution is ad hoc queries. But before we go to the next solution, I would just want to warn you not to go to your code and optionally compile wherever you can, because this has a huge cost on the CPU and memory, and on high load systems, this is not something that you would want to use. So I will show you a different way to get two different execution plans. This is with ad hoc queries, which are just concatenating input parameters. If the name is not null, I am adding to the where clause qname equals name, and if date issued is not null, I am concatenating to date issued the string of the date that I passed in, and at the end ordering by. I use this where 1 equals 1 dummy where clause, not to having to worry about which where clause was first, and to remove this and if it is not first. So I'm using this dummy logic here. Let me execute this query. And I will not bother you with the web application. I will just show you how this looks like when I execute it in the Management Studio. So first execution is with Brighton, second is with 11th of February 2018. The first execution got a non-clustered index scan, index seek on the index on the column name, and the second one got the index seek, non-cluster index seek on the date issued column. So basically what we are doing here, we are generating two different queries. Because these are two different queries, SQL Server has to generate a different execution plan for them. So we kind of tricked SQL Server and executed with execute SQL dynamic SQL, which has different queries. We can do this also by ad hoc with parameters. It's basically the same approach, but so we have ad hoc string, we have dummy where, and we are not saying concatenate and qname to name, but use the variable that was sent into the store procedure. Same here for date issued, and then in the param section we are declaring the parameters name and date issued, and passing the parameters into the execution of SP execute SQL. Let me execute this, okay. And the result is the same as before. We get index seek on name column and index seek on date issued column for the second execution of the stored procedure. So this is the end of the demo. These are the ways that I wanted to show you how we can resolve bad parameter sniffing problems. If you ask me which is my favorite way, it would be the last one that I show you. It is with ad hoc statements with parameters, because you join the two worlds. You have different queries for different input parameters, but you are obtaining the parameterization of the query. You're letting SQL Server to be able to parameterize this query and to reuse it if someone else calls this same stored procedure with the name like London or New York or something. It will reuse the query that is stored, the query plan that is stored in the cache. Okay, let's go back to the presentation. Now, I would like to say something about adaptive joins, which is a feature of SQL Server 2017. Why would I like to talk about this? Because it is kind of related to the topic. It is related to the topic because it is a way of SQL Server to resolve bad parameter sniffing on its own. What it does, it calculates adaptive join threshold, which is number of rows which the outer input, which is denominated by number 1 on this slide, has to input in, and if this number of rows is greater than the threshold, the adaptive join will use hash join, and if the number of rows is lower than threshold, the adaptive join will use nested loops. So here you can see the adaptive join operator, which if you want to see, you have to use SQL Server Management Studio 17.x. And with number 3, you see the cluster index scan, which is the inner table of the hash join. And you can see the 672 rows of 672 red. And with number 4, you can see clustered index seek, which was prepared for nested loops. If the adaptive join chose nested loops, then this cluster index seek would be executed, and you can see that it was not, because it has 0 rows of 336. On the next slide, we can see the use of adaptive join with nested loops. In this case, the threshold was again some number of rows, and the number of rows coming from column store index scan was lower than that threshold. So the adaptive join turned into nested loops, which we can see by looking at number 2, which has 0 of 672 rows. And at number 1, we have 1 row of 4 red, meaning that this cluster index seek, which was prepared for the nested loop, was executed. So this is a way for SQL Server 2017 to, in the runtime, choose which operator it will use based on the number of rows that are coming into this operator. So this is a pretty cool feature. This for now only works for batch mode operators. But I hope, I don't know if this is the plan, I hope that it will be also applied to the row-based operators. So we are at the end of the presentation with the conclusions. I would like to conclude and would like for you to take this away, that most of the time the parameter sniffing is good, and when it's bad, you have various methods that I showed you to deal with bad parameter sniffing.
Okay, thank you, Dan. That was a fascinating presentation. We have a couple of questions. I asked if you were planning on covering plan guides or how you address parameter sniffing when it comes from an application where we cannot access and edit the code or SQL being executed.
Well, if you are on SQL Server 2016 or 2017, I would kindly recommend using Query Store, because with Query Store you can very easily force a plan that you want to be used with your queries, and if you're not, you can use the SP create plan guide, but you have to somehow generate the execution plan that you are tending or wanting to be used.
There's another question. Could filtered indexes be a viable method of overcoming parameter sniffing problems?
Could filter indexes? This is a tough one. I don't know, really. I really don't know. No, I don't.
Okay. Is there a way I can tell from my plan cache which queries have bad parameter sniffing issues?
From plan cache. As I know, from plan cache, you can only take a look at the estimate execution plan. You don't get the actuals in the execution plan. So no, I don't think so. But parameter sniffing is a problem that you indicate by getting different durations and reads from your queries when you execute them. You get this information from your users or by yourself by doing load testing and some similar actions.
When would you use Query Store to force a plan for a query that you found to be affected by sniffing?
Well, Query Store has regress queries report that comes with the Query Store. When you enable Query Store, you get this report. And very easily you can indicate the query that has regressed. So is this because of parameter sniffing or by some other problem? That's not easy to conclude from Query Store, but you can very easily select the query execution plan that you want to force and force it through the Query Store regress query report.
Okay, that seems to be all of the questions. Thank you very much, Dan, for your presentation. If you will send me your PowerPoint and your demo scripts, I will post them with the recording. And I think I admire all the people who are capable of presenting perfectly competently in English when that isn't their first language. I could no more give a presentation in Croatian than I could fly. So thank you very much. I hope you'll have some more topics for us another time. And please let me know when you have something you'd like to present. And I'm going to end the webinar now. Thank you all for coming. We'll have another one April 25th, and I've forgotten what the name of it is. Thank you all.